Good morning, good afternoon, ladies and gentlemen, depending on where in the world you are. We even have a few attendees from East Asia for whom it's good evening. I have the pleasure to welcome you to the latest installment of our webinar series, Scientists Empowering Scientists. My name is Jan Dolzer. I'm the Director of Marketing at SATA Instrument. Today, we will talk about importing and exporting patch clamp data, virtual reality training in the biosciences, and about beveling pipettes. And the agenda, I will have a few brief introductory remarks, a little housekeeping, and then I will tell you a little bit about SATA Instrument. Then Telly Gaatsatos will talk about SATA patch data acquisition, management, and analysis software with a focus on importing and exporting data. Jake Spanswick, our guest from ClearPixel VR in the United Kingdom, a company that we have started a collaboration with, will talk about using virtual reality to transform the biomedical training landscape. And then Adair Österle will talk about beveling pipettes using the SATA BV10 beveler. And at the end of the webinar, we will have a combined Q&A and discussion session. If you don't have audio, you don't hear me right now, audio is transmitted over the internet connection. So if your computer has speakers, turn up the volume. If not, you can dial in. This is the US phone number. Dial-in numbers for the rest of the world can be found here, and the access code is this. I'll leave that up for another 10-15 seconds for those who do not have audio to write down the codes. It's also all accessible through the webinar control panel. If you have questions, please use the questions section in the session control panel. By default, that would be on the right of your screen. Please mention which speaker your question is directed to, so we don't have to guess on that, even though sometimes it's clear. And to avoid confusion, please do not use the chat panel around here. That makes it harder to keep track of who asked the question. All questions will either be addressed during the Q&A session at the end of the webinar, or if we don't have enough time, offline by email. In terms of documentation, we will have a video recording of the webinar available on our YouTube channel, where you already find a lot of other webinar recordings, and then also on our Youku channel for our customers in China. We hope to be done with that within the next 2 weeks. Youku sometimes takes a little longer, and everybody who has signed up for the webinar will be notified by email when the recording has become available. Let me switch gears and spend a minute or two telling you a little bit about SATA Instrument. 2024 marks a special year in that SATA Instrument has been around for 50 years. Like many good things, started in a garage and went from there. Here is a timeline over the past 50 years with not all by far, but just a few of the important milestones. One of them is the first instrument, the first product that we still make, the BV10 micropipette beveler, and Adair's talk will deal with that. I also want to highlight the P2000 laser puller, which is still in production with, of course, quite a bit of improvements over the years. Then Telly's talk will be about SATA patch software that we released in 2016, 8 years ago now, as the first product together with the IPA integrated patch amplifier, the first product in the amplifier system product line. So in 50 years, the founder, Dale Fleming, well into his 80s, is still in the office every day and very active in product development. SATA is privately owned, family-owned, employee-owned. We have around 70 employees. A lot of people think SATA is a much bigger entity. And being a privately owned company, we can pursue goals that a publicly traded company would not necessarily be able to pursue. I want to just highlight two. One is we want to be innovative, release at least one new product every year. And another goal is excellence in tech support. And what that means for us is we don't want you to be stuck in a phone menu, but rather you're connected with an expert that has scientific and or an engineering background with usually one phone connection. And that person has a good chance of knowing what you're talking about and possibly even better than you. I want to highlight the breadth of our product portfolio using the example of a patch clamp rig. You can buy everything around a slice rig, as shown here. From one hand, the somewhat worn out buzzword of one-stop shopping comes to mind. So here, for example, we make different types of micromanipulators. Products for micropipette fabrication, pipette pullers, glass capillaries, and other consumables, of course. We offer mounting solutions. You need to put the micromanipulator onto something. Shown here are gantry stands, but also platform stages, and then a microscope translator to move the microscope over the preparation. We make microscopes, upright microscopes, different styles. We resell perfusion systems, glass capillaries. We make software and acquired about a year and a half ago Wavemetrics, the maker of Igor Pro, the software environment in which Sudderpatch software lives. We make imaging products, light sources like the Lambda 721 and the TLED shown here, but also the somewhat more old-fashioned filter wheels and smart shutter. We resell equipment racks. We make amplifier systems, one of our major new product lines over the past 10 years. And we resell Airtables and Faraday cages. One thing that has started recently, but there was also at least one instance longer ago, is our products are being copied. We are kind of honored that our products are the ones that are considered the ones worth cloning, but sometimes the clone is a little smaller, a little fuzzier maybe. We do not out-license our products to other manufacturers. So if something looks like one of our products, but it's not Sutter branded, then it's not made by us. It's unlikely to work as well. It might even be totally different color here or a little shaggy. And of course, we can't support it, even if we want it. But if it's not our product, we couldn't even. With that, let me switch to introducing today's speakers. Let's start with the guest speaker, Jake Spanswick, who got a bachelor honors degree in computer games design from University of South Wales, and since 2020 is the CEO at ClearPixel VR. Then our first speaker today is going to be Telly Gaetzatos, who graduated in computer sciences from Queen's College in 1987, joined Instrutech the same year in various functions to be finally the general manager. In 2007, when Hika Electronic acquired Instrutech, he became the general manager at the American branch of Hika, Hika Instruments. Telly and I met at Hika, and since 2015, he's my colleague at Sutter Instrument, and today the product manager for the patch clamp systems. And the last speaker today is going to be Adair Österle, who got her feet wet with micro things in '84 at the MBL in Woods Hole, Massachusetts, graduated at Scripps in 1985, then did postgrad studies in biology at UCSB in '85 and '86. In '88 to '98, she spent time in various research functions at UCSF and the San Francisco VA Medical Center. And in 1998, she joined Sutter Instrument and is today the applications engineer and product manager for pipette pullers and a couple other products. And pipette pullers and bevelers, she's going to talk about that today. She also acted as a consultant and a contractor in 2 functions in Zika eradication research. And with that, let me switch to the first presenter of the day. Okay, we see your screen now, Telly. Go ahead.
All right, very good. Thank you. So thank you for the introduction, Jan. So my talk today will provide an overview of the various Sudderpatch data structures and discuss how to access, export, and import data. First, a quick overview of Igor Pro, which, as Jan mentioned, is the foundation for our Sudderpatch software. Igor Pro is an interactive software package designed for the analysis and visualization of scientific and engineering data with the main goal of producing publication quality graphs and page layouts. Igor Pro has been used by tens of thousands of technical professionals since it was introduced in 1989. I have been using it since 1990 when it was first a Mac II application. Igor Pro provides a complete scientific tool set to quickly analyze and graph large data sets with built-in statistical, curve fitting, and image processing functions. Igor Pro is a powerful programming environment with a full-featured symbolic debugger. It's a perfect environment for creating and testing automatic data analysis procedures and building custom graphical interfaces. There's no better example of its capabilities than our own Sutterpatch software. I would like to reiterate how powerful EaglePro is and that custom macros and procedures can be easily combined with Sutterpatch, as we do not block any of its features. If you have any specialized analysis needs, then there's no better toolkit, since there will be no need to export data or purchase any additional software licenses, as a 3-user license is included with all Sutter amplifier systems. As I was preparing this talk, I realized that an understanding of the Sutterpatch data structures and how data can be accessed was an essential part, especially when it comes to data export and presentation. So I would like to spend some time describing these various data sets. Our goal early on was to use as much of the native EaglePro behavior as possible. The packed experiment file was a perfect fit. With the release of EaglePro 9, HDF5 packed experiment files were also an option, but there were still limitations, especially for the high bandwidth data produced by our DPatch amplifier systems. Therefore, the option to store all the Sutterpatch data to a separate HDF5 file was added. Now, why use a separate HDF5 file? Well, 2 main reasons. One, only modified or newly added data are updated, which greatly improves performance, especially with large data sets. Typical PXP files from Igor are updated, completely updated with every saving, which sometimes could take a very long time. Accessibility via third-party applications that support HDF5 files directly. For example, I know of a number of users who are already using our files with MATLAB and with Python. File settings can be configured in the Set Preferences, Files and Naming windows. An experiment file is always created, but with this option enabled, it would only contain Igor-specific objects. What do I mean by that? A custom layout, graphs, results from custom user macros or procedure files will all be stored in that experiment file. At the very top of our data sets are the individual signals. Signals are either acquired, created by a virtual math instruction, or imported. Each signal data is stored in a 2-dimensional 64-bit double precision or 32-bit single precision floating point wave. The wave has X number of rows, computed by sweep duration times sample interval, with N number of columns for each sweep. Default data precision is 64-bit, which can be changed in the Set Preferences, Files and Naming window. Virtual signals will always be 64-bit double precision. Also, Sutterpatch data is always stored in native units. Amps, volts, etc., always properly scaled. Unlike other data acquisition applications that require several gain and offset factors to be applied to have a valid data set. There are a variety of analysis results created in Sutterpatch. They could come from real-time measurements and graphs, which were executed during series acquisition or during post-hoc reanalysis, or generated by one of our analysis modules, either action potential, synaptic event, or single-channel analysis. Analysis results can be easily accessed from the Analysis Editor window. Analysis results can be either shown as a table or graph, and they could have different wave formats. Tables are stored as 2-dimensional 64-bit double precision floating point waves, where rows are the sweeps and each column has a specific result. Dimension labels are used to properly mark the columns. Sutterpatch provides table formatting settings in the Set Preferences Data Export window for making these waves easier to read and export. As I mentioned earlier, we use native units for storing the data, but for display and export, the table data is parsed based on these settings. A powerful feature of Sutterpatch is the metadata stored along each data set. Metadata comes from a variety of auto-generated system parameters, for example, amplifier or data acquisition settings, or from any number of user-selectable parameters. These parameters are all based on the selected metadata levels specified in the Set Preferences metadata window. The full detail option provides the ability to select from over 600 parameters. Now, you don't have to use all 600 parameters, but you have many options to choose from. Metadata is stored in a 3D text wave, where rows are the meta parameters, Columns are signals, and layers are the various meta tags. Again, dimension labels are used to properly mark the meta parameters. The experiment structure reflects the structure of the experiment file, i.e. the sequence of paradigms and routines that were executed. This is a single two-dimensional text wave with dimension labels for each column. Speaking of routines and paradigms, routines and paradigm copies are stored as well, but those waves are encoded and cannot be read directly. More on that later. Finally, images, either acquired via our camera module or imported, are stored in a 3D wave using PNG encoding. Okay, now let's access these data waves. All the data waves that I just described exist within the Igor Pro environment, which can be viewed with the Igor's data browser. For most Sutterpatch users, they will rarely need to look at the individual waves, as Sutterpatch provides several editors to organize, view, and in some cases modify. If you're writing your own macros or procedures, the data browser can be very useful for getting a variety of wave information, as well as tools for viewing the data as a graph or a table. For most users, the Data Navigator window will be the main access point to visualize, analyze, export, and import data. The data is displayed as a tree structure with the name of the experiment file at the very top, followed by paradigms, either auto-triggered or planned, which may or may not include a routine level with signals and sweeps. The Enable Marks feature allows selecting or unselecting data for display, analysis, or export. A variety of options for marking, unmarking, including equations and value lists, are available from the right-click menu. These options will change based on the selected tree branch. The Data Navigator also has options to filter the data tree based on specific metadata parameters. Single or multiple metadata parameters can be selected. Enabling the tree filter will recreate the data tree with only the relevant entries. In this example, only series that included signals acquired in current clamp recording mode are shown. Please note that this filtering has no impact on the actual stored data. Now I would like to review some of the options for the various tree levels. First, the paradigm level. In addition to the exporting, marking, and unmarking options, a useful feature is Review Paradigm. This selection will display a time course overview of all the acquired series within this paradigm level with the appropriate timing information marks. The info section, shown here, will provide links to paradigm-specific information. For example, if a planned paradigm was used, then a copy of that paradigm would have been stored, which can be viewed by selecting this link. As I mentioned earlier, this copy is encoded, but it can be easily copied to your active paradigm pool where it can be used and/or modified. If images were stored, individual links to those pictures will be shown as well. As I mentioned earlier, metadata has many layers. A link to the paradigm-specific metadata would be available in the info panel as well. Favorites can be defined in the same way as with the Data Navigator filtering. Metadata parameters can be sorted either by event, parameter, or by favorites. This metadata filtering and sorting is available on all tree levels. Like the paradigm level, the routine level has its own options as well. Review routine will provide a time course overview of the acquired series. The info section is updated for routine-specific information. A link to the routine-specific metadata with the same review options as described earlier, a link to any real-time measurements and graphs stored in the analysis editor, and finally, a link to the routine copy for displaying routine settings and/or dynamic clamp settings if they were active. As with the paradigm copy, the encoded routine and dynamic clamp settings can be copied to their respective pools. A good use scenario here would be to replicate an experiment from a shared data file. Copying the pool entries would allow you to have the exact settings without having to manually enter them, which will allow you to replicate the experiment of that data set. Finally, the signal level. As you see, there's no info window, just an expanded preview. The unique options that I would like to point out is starting one of our analysis modules, averaging sweeps, and displaying and editing the signal data in native Igor graphs or tables. You may have noticed that there are two graphs shown. The one on the left includes only the marked sweeps, while the one on the right is all the sweeps that were acquired. Throughout all the various levels that we just saw, there was data export selections. Data export uses predefined settings that are set in Set Preferences data export window. Shown here are the various file types that can be used. Each file type may have specific options that will also need to be set. For ABF format, we use header version 1.85 requirements. The second option is for copying and converting data within Igor. No external files are created here, just waves in the specified target folder within the Igor environment. This option was added for customers who had custom analysis functions that required 1D waves, and we expanded on it to make it more usable. Throughout the various Sutterpatch windows, we have the copy to control. This control provides the simplest tool for exporting, either directly to the Sutterpatch notebook or to the clipboard for pasting into other applications. The Sutterpatch notebook has a special version of this control as well, which includes printing and saving the notebook contents. With version 3 of Sutterpatch, the notebook window can handle any combination of graphs and text. Sorry, what I didn't mention before, that all the windows that I show here and all the options are with Sutterpatch version 3. As I mentioned with the analysis results, the copy to control also uses the table formatting preferences. One quick note, if you're pasting into Excel, exponential notation data is required, otherwise it will not be properly read. Copying to an Igor layout page provides all sorts of publication quality options, as each item in the layout page is its own unique object and it can be handled any way that you would like. You could expand it, you could change the grids, you could change colors, anything that you would like, and then that page can then be printed or stored as a PDF. All graphs in Sutterpatch have native Igor options available via the right-click menu for modifying, exporting, and then saving or printing these graphs from the file menu. Now that covers most of the export options. Now let's talk about data import. As mentioned earlier, data import is handled from the Data Navigator. Importing data, whether it be a Sutterpatch experiment, a Sutterpatch HDF5 file, Patchmaster, or ABF file, would be added to the current experiment file. Experiment files can have any length and include as many data sets as needed. Importing various experiment files into a new file will allow you to organize all the data into a single file while leaving the original files intact. So if you have a paper that you're working on and you want to put specific data sets into a file to go along with it, this is a nice, easy way to do it. Within this new modified file, you could also do things like discard routines and or paradigms. ABF file import is limited to ABF 1.85 and above files, ABF 2.0 to 2.09, and why they're separated is because they have different header types. We only support gap-free and episodic stimulation modes. I believe ABF, it's mode 3 and 5. There are several limitations with channel signal assignments that Sutterpatch relies on, but is not directly available in ABF files. Every effort was made to predetermine these settings, but user confirmation is required for the import to continue, and that's done through this map channel connections window. One more thing that I would like to mention, we have seen many ABF files that were created by third-party applications that do not adhere to the ABF header requirements, which may lead to either a failed import or very strange settings. For Heka Patchmaster, we support their so-called 2x80 data files. Patchmaster Next uses a different file format that we are currently working on. Now, one last bit of general information that may be useful. Igor Pro tutorial videos are available on their website, while ours are available on our YouTube channel. Well, with that, I'd like to thank you for your attention and I'd like to pass to Jake.
Thanks a lot, Telly, for a very comprehensive talk about Sutterpatch software and the capabilities with import and export. Jake, we're seeing your screen. Take it away.
Excellent. Thanks, Telly, and thank you, Jan, for the introduction. Yeah, my name's Jake. I am one of the founders of ClearPixel VR. I figured I might just quickly run through a little bit of background as to who I am and how I've got to this stage here in our collaboration with Sutter. So I myself have a degree in video games development, which is probably an odd crossover for this particular webinar, but the background as to how we got into this area of neuroscience and biomedical science is that my dad is actually a neuroscientist, specifically in electrophysiology. And a few years ago, we discussed the lack of support in the education system for training on practical science, in particular labs who were struggling on the university scene in terms of delivering in-person training for their students. And we quickly realized that with our background in video game development, we could actually use virtual reality as a tool to leverage a solution to a lot of these training problems. So that's a little bit about me in a nutshell. What is virtual reality? And I'm going to focus for this purposes on VR exclusively. There are a number of other extended reality tools out there, but for this particular project, we are talking about VR. So VR is essentially the digital simulation of reality. In a complete sense, it's immersing people in a 3D environment, and it is limited to that environment. So you have full control over 3D interaction and immersion. It also includes multi-sensory engagement. So whether it's haptic feedback, audio, visual cues, it's essentially putting people into a world that extends beyond reality, that you can manipulate and use to, in our cases, train people. In many cases, it's to entertain people. And there are a diverse range of applications these days. Virtual reality is becoming more and more popular, and I'm going to go into a little bit about some of the technology that's out there at the minute before going into what we are doing at ClearPixel VR. But it's playing a big part now in healthcare, surgery, engineering. Organizations like Amazon and DPD are using it for their logistics departments. So it's become a much more widely used tool, and I'm sure that many of you may have seen in the news the Apple VR headset, which has garnered a lot of attention recently. But yeah, VR is becoming more and more prominent in industry, and in particular in training. So there's a few big players at the minute, and we actually optimize our projects for a lot of these headsets and hardware. So moving from left to right, we actually have the Apple Vision Pro, which is proving to be the most popular consumer VR headset at the moment. It's a very powerful tool for consumer use, things like creating documents, organizing your workflows, and general sort of day-to-day workflows. Moving to the right, we have the Meta product, which is in this particular case, the Meta Quest 3. Meta have, I guess, kind of adopted a different angle with their virtual reality, as they started out with entertainment and they've slowly moved into training. I believe we've probably all heard about Meta's push to create what's called the metaverse, something that essentially involves more and more people adopting virtual reality and using it in their day-to-day lives to extend their own sort of reach as to what they can do, whether it's learning new skills, understanding new concepts for entertainment, etc. They've kind of led the way in that field. And then if we move further along to the third image there, we have the Pico 4, which is an Asian brand and what is becoming essentially the rival to the Meta Quest. It's a phenomenal piece of kit. We use them ourselves in our training, and we actually find that it's one of the best enterprise level pieces of equipment out there. It's extremely powerful, and these days you can simulate things to an extremely high resolution. I'll go into more of that in a second, but it's a phenomenal piece of kit. And then we have the Vive Pro, which is a product by HTC, which is, again, another industry level training tool that people are using more and more in their training workflows. So a little bit about what we are doing specifically, because it's still quite an early stage for us. We are a startup based in the UK, and our mission is essentially to help organizations scale their training programs to deliver engaging learning and assessments for their students and staff. And what does that mean? Well, essentially, we are trying to help people understand and learn better skills in their labs. And we're doing that with VR. You can control a lot of things in virtual reality, and it offers a very scalable solution to what is becoming quite a big problem, and that is that people, particularly in education, can't get the right level of practice on certain pieces of equipment, on certain techniques. And that's how it all started. So for us, this all began in education, and it's quickly escalated into what is now more professional training as well. We actually have the ability to train multiple groups of people remotely and in different locations. So it solves a lot of geographical issues for not just universities, but also for corporates as well. And we can do so in very highly dexterity-based scenarios, whether it's learning how to pipette correctly, or in our collaboration with Sutter's case, we actually have a virtual patch clamp rig, which I'll give a bit more detail on in a second. You can actually train people to an extremely high degree of accuracy in virtual reality. And it's very beneficial for the individuals who are learning in this, but it's also highly beneficial for the organizations who are engaging with the training as well. Research shows that it saves enormous costs because you are not having to spend money on consumables, and you can actually deliver more training on scale quicker. So you don't have to organize large groups in labs, and you can just essentially run, I guess, what we're calling a virtual lab instead. We're also looking to develop and incorporate multilingual learning and instruction, because we know that in the case of being in the UK, we have quite a large volume of international students who come through universities and the education system. So we are actually working on a means for multilingual communication in VR. So when an instructor talks to their class, the group that are there watching and engaging with their practical learning all get fed their particular language and instruction to them, which is a phenomenal tool, especially for international students, because we've had a lot of organizations say to us, we need to deliver training better for multiple languages, something that we are quite excited to be a part of working on. And then, much like a lot of companies at the minute who are starting to incorporate AI into their tools and technology, we are working on an AI assistant, which essentially tailors learning feedback for users. So when you're engaging with our virtual training and assessment, a lot of your metrics are fed back to a dashboard, so that you can review the things that you're looking at, where you're going wrong, and learn from those mistakes, so that when you get onto the real tools, you should have a better handle on how things are operating in the labs. I've got a little video here that kind of runs through a little more context as to what we are building. So you can see here from this perspective is our lab. In particular, I believe this module is an intracellular solution preparation module. So it runs through the key components, the key ingredients. This one actually is an ACSF solution, so that's a slightly different mix of components. But you can kind of get a feel for what we are building and what we're doing with the minute. You can see here some of the Sutter equipment. Essentially, we've created a virtual space where people can learn any number of techniques, and we do at the minute have a list. I'll go into more detail in a second. But in a nutshell, we are delivering high-end skills through VR to universities and organizations. And there's research out there. It's quite early on in terms of virtual reality being used as a training tool. So the research that has gone into where it sits in terms of how much it can save organizations, how it increases training, is still relatively adolescent. But there are a lot of studies at the minute in healthcare in particular, where VR is playing a big part, that shows that VR can actually save organizations up to 52% on their training costs. And that's from whether it's equipment damage, consumable waste, direct staffing costs. You can essentially take an entire class in a lab and deliver it in VR and save up to 52% on your costs. It increases training efficiency by up to 400% because users are actually engaging with their equipment and they are contextually learning to a higher level than they would be just through, for example, running it once in person or learning from textbooks and from videos and images. And ultimately, it improves confidence. A lot of people who engage with our virtual learning tend to say that they have either never experienced the practical that they can learn in VR, or they have never been around the equipment that they can learn in VR in person. So they are getting exposure to what are quite difficult things to get in front of in real life. Now, our collaboration with Sutter is quite an exciting one. We were lucky enough to meet with the team just over 12 months ago at the Society for Neuroscience, and we started to discuss a means of essentially incorporating real industry equipment and designs into our virtual lab, so that when we build our procedures, people are actually learning on real equipment, not just some white labeled microscopes and manipulators, etc. So a couple of images here that are quite exciting is part of our patch clamp rig, which Jan showed a couple of images at the beginning, but this is what is our fundamentals of patch clamp module, where you can learn about the various techniques and the equipment that you'll be faced with. In this case, it is using the Sutter ROE 200 and the MP245 manipulators. Now, in particular, this module is actually extremely popular with universities on neuroscience courses, because so many organizations can't deliver as much training, especially to undergrads who, at the risk of breaking the equipment, or people who aren't as skilled and adept to deliver the training are in the department. So universities in particular are quite excited by this. And moving forward, we're quite excited by some of the other opportunities that we have with Sutter. I know that some of the individuals, Jan included, may not have seen yet that we are working on their Model P 1000 micropipette puller. It's something that we've been working on for the past few months with the Sutter team, and we're quite excited to share that we are working on a module specifically for an introduction to pulling pipettes. It's something that universities in particular, especially students who are breaking into their neuroscience programs, and these are pieces of equipment that they don't often get to try out or see, and this is an excellent, safe way, it's quite practical way to train them on very high-end equipment. Now, looking ahead and what we currently have, so our VR modules at the moment are specifically focused on neuroscience techniques. So we have an ACSF solution preparation module, as well as an intracellular solution prep module and the fundamentals of patch clamp, all kind of linked together in a way that you're learning those sort of basic neuroscience modules as part of your education. We also have 2 pipetting modules, which is something that has become a bit more prominent from universities who want to deliver certain technique training. So we're actually building a large list of fundamental modules moving into 2024. I think you can probably see the future of our platform this year involving a few modules in PCR, ELISA, Western blot, and then we have some specialist modules, particularly in pulling micropipettes and microsectioning devices. And we're going to be incorporating our multi-user and AI assistance training this year as well. And then looking ahead, because the goal of this is to essentially build a virtual training compound where students and professionals alike can learn about various techniques, whether they are fundamental to biomedical science or more specialist in neuroscience, for example. We essentially want to build on what we already have and create what is to be a virtual compound. I'm going to leave that there for now. I imagine there might be some questions at the end, and I'm now going to hand over to Adair.
Thank you very much, Jake. That was a very interesting talk, and I'm also excited about our collaboration here to the mutual benefit of both ClearPixel VR and Sutter Instrument. ClearPixel benefits from our input by making sure that the equipment behaves like the real equipment would. And the benefit for Sutter obviously is exposure. If people get trained on our instrumentation, they are much more likely to actually buy them from us as well. With that, Adair, we're seeing your screen, your presentation. Take it away, please.
Can you hear me all right?
Yes, absolutely.
All right, great. Hi, my name is Adair Osterly, and we're going to discuss the beveler and how to bevel a pipette, and firstly, how to actually put the beveler together. As Jan had mentioned, the beveler is the first product that Sutter made, and the story goes that as long as we sold 12 bevelers a year, we would keep the business running. So that was back in 1974. Obviously, we continued to sell 12 bevelers a year, and we still do now. So we're still up and running, but we actually have a lot more products in our catalog. So let's proceed here. We are going to be making some sharp and hopefully beautiful pipettes. There are ways to make really ugly, terrible, awful ones. So we'll go over that too. Not that that's your goal, but it is a goal to avoid that. So the outline of what I'll be discussing. I hope I'll hit all the topics. I made a lot of slides, and we'll see how fast I can go through them without having you guys try to run behind me to keep up. So first, we're going to go over what is beveling and the applications that require beveled pipettes, assembling the beveler, how to find the frigging pipette. It is very hard sometimes to find the pipette. And I have a few tricks that'll help you find it and make the process hopefully enjoyable rather than a pain. Lighting, the lighting is very important. The earlier bevelers, the first bevelers we sold, did not have their own light source. We did eventually add a light source, but it was a bit weak. And now with LEDs, we have a very bright light, and that helps. You can also add a light yourself if that is required, but we'll go over that. We're going to go over the glass, the tools, and the solutions. Beveling small and large tips. How long does it take to bevel a pipette? Beveling at various angles, and then discussing the taper length of the pipette that you can actually bevel. If it's too short or too long, you're going to run into some issues. So you're going to go from ideal to impossible. And then discuss the tip sizes, what's doable and what is challenging. What is beveling? Beveling is when you're grinding the glass at a diagonal to create a sharp and angled and more durable micropipette. Here's an example of a beveled pipette. Isn't that gorgeous? And then you'll be using the Sutter BV10 beveler, which is shown here. And you have a light, and there's a microscope. The beveler doesn't have to come with a microscope, but it's very hard to use it without it. And you really need it at that angle, too. The section scopes, you might have something on a post that swings over. People have tried that. It's not very useful. So it's really best to get the scope with this beveler. And then they also come with a meter if you're going to be doing electrophysiology. I will not be discussing meters and the use of the beveler for electrophysiology, but you can call Sutter if you need more information on that. Here is the preview here of beveling a pipette. I'm going to show this. It's a fast motion, so you can see it. It's not always as fast. It usually takes many seconds to maybe a few minutes. But isn't that gorgeous? The next thing we're going to go over are the applications that require beveled pipettes. Beveled pipettes are required when the tip must cut through thick tissue, through a tough cell wall or an egg that has a fibrous membrane or a chorion. And examples of these applications that it's required for would be brain and spinal cord injections, Drosophila, mosquito eggs, shrimp eggs, fish eggs like Medaka, moth and butterfly eggs, plant cells, wood cells, and pollen, zebrafish, and frog eggs. Don't always need them for that, but usually people just trim the glass back and they don't need to bevel. But if you want to bevel, you can, and the pipette lasts longer. Adult insects, they can be used for. Cephalopods, the eggs of cephalopods, octopus, squid, and cuttlefish. Pronuclear and cytoplasmic injection applications like CRISPR, when you're going into a mouse egg, or you're doing nuclear transfer or stem cell transfer or ICSI. The glass types that you can use are borosilicate, aluminosilicate, and quartz. Borosilicate is a good glass, a little softer glass than some of the other glasses I'm going to show here. Aluminosilicate is better because it's 10 times harder than borosilicate. And then quartz glass is best, and it's much harder than borosilicate, 15 to 20 times harder. It's the most durable glass that is available. It's easier to bevel because it's so stiff and it grinds back really quickly. It stays sharp longer and it won't dull as fast. When I was doing some microinjection work with mosquito eggs, I think we hit a milestone of 537 injections with one pipette. And then it finally broke or got dull and broke. So it was a sad moment, but I was very thrilled that it lasted so long. And then everyone who's going to be using quartz glass must use a P2000 laser puller. And that has enough heat to melt the quartz. The P97 and the P1000 pullers don't create enough heat to pull quartz, so you'll need a P2000 puller. And these are some glasses that I recommend. There are lots of different glasses we offer: thick wall glass, thin wall glass, filamented and non-filamented. And then here are the examples of the pipettes, what they look like when they're beveled, and the glass that I'm using for this. The top is thin wall, then you have thick wall, then there's solid rod glass, and then there's filamented glass, which is required when the tip is small. The filament in the glass helps create capillary action, so when you backfill the pipette, the solution goes to the tip without forming bubbles or not flowing to the tip at all. Okay, we're going to get started here with assembling the BB10 beveler. Here's the beveler base, and there it comes with a base and power cord. And there's the newest version of the light that we have. And it's focusable, which is kind of nice. And that is the top of the pedestal pair. That is the part that holds on to the beveling plate. And then here are all the parts that come in the box. Again, the beveler and the power cord right there. You have the beveling plate holder. You have the micromanipulator right there. There's a wick holder and a wick right there. There are 2 beveling plates that come with the beveler, and you can select from 4 different grit sizes of beveling plates that I'll review soon. We also have the microscope and the mounting rod and hardware. And you can also optionally get 20x eyepieces, which allows you to see at 80 times magnification, which is best for tips that are under 10 microns. Those are the eyepieces there. And then last but not least, the degreaser and the beveler oil, which you need for cleaning, and also the oil is used, as you'll see soon. Additional supplies you might need are here. As you see, I've labeled the far left bottle of ethanol 76.875%. That's so no one takes it from me. It's different, and they don't think it's something that they should use, so they don't take it from me. But anyhow, there's the other supplies that are there. And I use medical grade water and medical grade ethanol. They don't have any additives in them. And for cleaning of the glass, you would use ethanol and water. And then for the cleaning of the beveler itself, the parts, you're going to be using water and maybe a degreaser and ethanol for the parts that are oily. And then the top beveling plate, you're just going to rinse it with clean water. So assembling the beveler, the first part is putting on the eyepieces. It comes with 10x eyepieces. If you bought the 20x, you can put those on there. The little Phillips head screwdriver you would use. And here are the mounting rods and the mounting block and the mounting post. And first you put the mounting post on and you put it on super tight because you're going to be using that as a pivot point, and it's going to hold on to the microscope. This is the mounting block. The line right there goes up and towards you. And so that needs to have the proper orientation, and I'll show you soon why that is the way it needs to be installed. That's the microscope mounting rods, and then you're going to assemble that, and you're going to put that together super tight. Step 2, you're going to slide the rod into the mounting block, and you're going to line up the line there you see with those little divots. And that will create a situation where the microscope is at the right angle for the best viewing of the beveling plate and the pipettes. And so you're going to tighten that super tight, and you're going to tighten this tight. It is a pivot point, so you want it to slide a little bit there, but not have it too loose. You want some control. Step 3, you're going to remove the cap. You're going to loosen the knob, and then you're going to slide the post through the hole, and you're going to mount the scope, and you're going to slide the scope all the way down to that ring stop shown here. You're going to tighten the knob to lock the microscope in place, and then you're going to adjust the focus knob on the scope so it's flush with the base, and that will be a good starting point for you right there. Then you can put the cap back on, and then you're going to put on the wick and the wick holder. Step 4, you're going to select a beveling plate. We have 4 different grit size beveling plates, and they go from coarse to extra fine, and they all are color coded: copper, lavender, gray, and sage. Copper and lavender are the ones I use most often, and you would select the beveling plate based on what tip size you're going to be beveling to. You're going to remove the retaining ring, and then you're going to put the beveling plate onto the bottom part of that assembly, and then you're going to attach the retaining ring. And you want to tighten all the screws snug tight, and I usually go around like I'm tightening the lug nuts on a tire. If you've ever changed a tire, you're going to go around and just do a little extra tight, tightening all the way on all 3 screws so it's evenly tightened. Now, step 5, we're going to continue with the assembly of the beveler, and we're going to add some oil to the top of the optical flat, and the beveling plate is floating on that optical flat on oil. And that's what makes this beveler so amazing, is that it's rotating, and it's rotating perfectly flat, and there's 0 up and down vibration or movement of the beveling plate. So you only want to put 1 to 2 drops of oil. If you put more drops, you're going to have an oil slick. So don't do that. You're going to have a crazy oil spill. And you're going to turn the power on first, and then you're going to actually put the beveling plate on top. And I'll show that to you. If you assemble the beveling plate on top of the bottom base, all the oil will go away. And if you put the beveling plate on top and you don't have the beveler rotating, all the oil will go away. And when that happens, the beveler starts jerking. So you want to avoid that. Step 6, we're going to get the manipulator out and set up. You're going to remove the strap. This is what holds onto the pipette. You're going to make sure that the toggle plate is in the proper position, like that. That is correct. That is wrong, and that is wrong. The plate has flipped over. So you want to make sure it's in the correct position. And then you're going to adjust the pivot point to position number 1. That's a very good position for when you're adjusting the fine dial for lowering the pipette. It's a nice gentle rate of lowering of the pipette onto the plate, the beveling plate. You're going to dial the coarse knob all the way up, and you can see that the angle plate holder is almost flush with that top part of that assembly. And then you're going to dial the fine focus to around 9.5. That's where that toggle plate right there is level, and that's what you want. You want to make sure that you start with that every time you're starting to bevel a pipette. You want to re-level that with the fine dial. The next step here is creating the angle that you want. So you're going to adjust the angle plate, and then you're going to lock it in place with the locking screw. And then you're going to put the wick off to the side on the beveling plate. And then you're going to add water, which has a little bit of detergent or photo flow in it. Why do we do that? Because that breaks up the surface tension of the water. And so the water will lay flat on the beveling plate and it won't puddle. If it's puddling, you're beveling dry and wet, and then you'll end up with a lot of dry glass particles in your pipette, which will clog the tip. So you always bevel with a wet surface, and that is what the wick there is for, and that is what the water is for. The water you're going to add, so it's about 1 millimeter thick. You're then going to position the manipulator onto the beveler base plate, and I usually mark it with either a Sharpie or some tape. So that is the position I like to have everything stay so I can find my pipette more easily when I go from one pipette to the next. We're going to also go over here quickly the taper length, tip size, and the time it takes to bevel a pipette. 3 to 5 millimeters is a bit too short usually because you have a high cone angle. It's like more like a patch pipette, and the tip will get beveled too fast usually, and it'll be hard to bevel to the tip size you're really wanting. 5 to 10 millimeter taper length is ideal. 10 to 15 can become challenging because the glass becomes a little too flexible. And then over 50 millimeters, it's possibly impossible because it's way too flexible. So here's some taper lengths here. The first one being a little too short. The next 3 in a row are doable. And then the one at the end, that would be pretty much impossible. But those taper lengths that are really long are the ones that you're normally going to be breaking back to make, say, a 15, 25, 50, or 75 micron tip. So you pull along and then you'll be breaking them back. The tip sizes that are possible to bevel are under 0.5 microns, but it's hard to see. 1 to 25 microns is easy, no problem. 25 to 75 microns is easy, no problem. And then when you get to the tips that are larger, it's doable, but it takes longer. And then once the tip is really large, you're going to run into problems because it's too big and there's too much glass volume. The time it takes to bevel the pipettes, anywhere between 5 to 60 seconds, depending on the tip size that you're aiming for, and then up to 1 to 5 minutes if the tips are really large. If you go to the webinar titled Achieving the Impossible, 17 minutes and 55 seconds into that webinar, you will see information about how to score and break your glass to get a clean break before you bevel large tips. You need to get rid of all that glass first, that's smaller, and then you will put the tip on the beveling plate to bevel. If you're making a small bevel tip, you just pull it and you just bevel it. And you don't need to cut it or trim it or forge it. But if the tip is somewhere in between sort of a small and a large tip, you do need to forge it. The 5 to 15 micron range, you need to cut it or trim it with some tweezers or scissors, or you need to use a microforge, and that cuts the glass at the tip size you need, and then you would then bevel it. Again, that's usually between the 5 and 15 micron tip sizes. Okay, now we're going to bevel the pipette. Step 1, you're going to put the glass into the holder. There's a little clamp there, rubber washer, and then there's little grooves that you put the glass in. I always place the glass at the same location on my index finger, middle of my pad. So I'm always loading the glass at the proper length. So when I drop the glass down and I look through the microscope, I can more easily find the pipette tip. So right there, you see the glasses against the pad of my finger. Then I always have the finger touching the black block before I tighten the clamp. Then I'm going to use the coarse dial to lower the glass to the plate to be just above the water or barely touching the top surface of that water. And there's the coarse dial right there that you're going to use. So here we are, and we're turning that dial clockwise to lower the glass, and then you'll see where when it finally touches the water, you'll see the water actually go into the pipette there a little bit too. The next step, what you want to do here is you want to find the pipette. That's why I titled this How to Find the Friggin' Pipette. It's very hard if you don't go through specific steps. The number one trick, the first thing to do is to focus on the back edge of the retaining ring, right there where the blue arrow is. You're going to focus on that. You're going to push the scope forward until you see the black edge, and you're going to focus on that first. This is like focusing on the edge of a water drop to find the bottom of the water and where the surface of your slide or the Petri plate is. And now I'm going to slowly pull the scope back towards me and maybe slightly pivot it right to left to find the tip. So I'll show you that right here. I'm just pulling back a little bit, pushing forward. This is how you're going to search for the tip. You're going to also maybe toggle the tip, pivot it actually right to left a little bit to find it. This is what you do not want to do. Do not tilt the scope forward or tip it back. If you do this, the pipette will get lost. You'll get lost, and you might just go crazy trying to find the pipette. So don't do that. The next thing you're going to do is when you've found that edge of the retaining ring on the beveler, you're going to slowly pull the scope back towards you to find the pipette, the reflection, or the shadow. You'll see something eventually, and you'll focus on the pipette. Don't let the reflection of the shadow fool you, and I'll show you what I'm describing there. Then you're going to adjust the light. You're going to slightly pivot the scope right to left to get it centered in your view, and then you'll refocus, and then you'll lower the pipette to the surface. And I'll show you that right here. I'm pulling the scope towards me. I see a little bit of a shadow. I see a reflection. It looks like the pipette's aiming up, but that's actually the reflection of the pipette. So I want to focus and find that pipette that's above. There it is. And now my reflection at the bottom is now a shadow. And now I'm going to lower the pipette so it's just touching the surface. And the lighting is key here, and sometimes it's challenged to find the right lighting, but I'm going to show you the bad and the good lighting. And once the lighting is adjusted and you have the proper amount of water to get the meniscus out of the way, and you can see through the water, you'll be able to see the pipette. And you're going to use the coarse dial to touch down to the plate, just barely. And then you'll use the fine dial to gently touch the plate and then advance the tip downward so you can bevel the pipette. And you're going to look for a very slight bend or bow of the pipette, very slight. A quarter turn usually gives you 0.5 to 3 microns if your pipette has not been trimmed or cut back. Half a turn gives you 3 to 5 micron tip. 3/4 of a turn is good for a 7 to 10 micron tip, but sometimes you might need to trim it first. And then for tips that are over 20 microns or larger, you're going to need to, again, trim it back, and then you're going to do usually 1 full turn, maybe 2 or 3 if the tip is really large. This is the fine dial, and you can see I've marked it, and I've put the tip sizes there just as a reference. But usually I have that front mark there where it says 20 microns. I have that front mark there all the time, so I know how many parts of a rotation or full rotation I've taken. And then here is a video showing the pipette. I'm moving the lighting around. I can't really see much at all. And I'm just moving that lighting. Oh, that's good. And I'm just going to move the lighting until I get something good. Once I touch the water, the meniscus is in the way, and then I can't see anything. So that's going to drive you crazy. So then you need to move the lighting around a bit more to see through the water. If you can't see through the water, you're going to add some more water so that meniscus raises higher and is out of the way. So you'll see that eventually. I'm still playing with the lighting here. You'll see how hard it is. Okay, now I have a good lighting, and now I'm going to add some more water. And that'll bring that reflection, that meniscus, above the pipette. I'm going to add a little bit more. Now, my water in this situation wasn't totally clean, so you'll see a few pieces of crap fly by, but you'll see what that's like. And then when you touch the plate, you'll see the meniscus of the water inside the pipette go up the pipette. See that happening right there? Isn't that cool? That's when you know you've touched the bottom of the plate. And now you see a little bow there. That's when I just put like a quarter turn or a half turn on that fine dial to push onto the plate. See, there's a little bit of dust that was in there. And then after about 15-30 seconds of beveling, if I'm beveling a small tip, I'm going to raise it up with the fine dial. And then I'm going to raise it up further with the coarse dial to remove it. There you go. Now, if you push too much, here we are beveling some large tips, but I'm showing you the proper amount of pressure and then not the proper amount of pressure. So 2 to 3 full turns is good on the fine dial if you're beveling a really large tip. 4 to 5 rotations is too much, and it's going to be somewhat disastrous. So try not to do that. When you push too hard, it changes the bevel angle. You end up with a tip that the absolute end of the tip never sees the plate, and you get the squared off blunt tip. I'll show that to you here. And the tip will fracture, it'll chip, it'll break back. You might start crying. So don't do that. So here we are, I just touched the plate. I'm going to drop it down. Now I'm going to use the fine dial, and I'm going to make 1, 2, and then 3 full rotations. Now it's beveling. Now, the trick is here to be patient and not sit there and try to push more on the plate because you're tired of waiting. It might take a minute or 2 here. And once it actually has completed the bevel, it's good to lift it up gently with the fine dial right when it's done beveling. Here I'm showing you pushing even further. I went 2 more rotations down. Now you can see how I've changed the bevel angle, and you see how the tip's not even seeing the plate. The back part of the glass is beveling, and the tip is not seeing the plate. It's just staying as this little blunt, broken, or actually not really broken, but just this blunt tip. Now it starts to break, and there's just so much pressure, it's chipping. You might think that thin part in the front is really nice and sharp, but it's so thin, it's fragile, so it'll break. So beveling at a really low angles, like 15 degrees, I really advise people not to do that. And now I'm raising the tip back up to get something more reasonable. And then once I've got a nice clean bevel there, I'm going to stop. The other thing might happen when you push too far down on the plate. Remember how the absolute tip wasn't seeing the surface? Well, that happens on smaller tips too. And when that happens, you get this little spike at the end of the pipette. Now, that spike is really just a flimsy spike, and the tip is pretty blunt once it breaks off. So you don't want that spike. And when you bevel aluminosilicate glass and quartz glass, you're more likely to get that spike, especially if you push down on the plate too hard and too quickly and too far, or you're beveling at too low of an angle. So you really want to avoid that. Step 5, here's what I do to remove the pipette and install a new one. I don't want to move the scope. I don't want to move the manipulator. I don't want to move the light because I spent so much time getting it perfect. So I'm going to reach in from the side, and I'm going to spin that little locking screw, and then I'm going to take the pipette out. So again, don't move anything. Gently reach in from the right side. Again, not disturbing anything. And then spin that little locking screw, and then take the pipette out. And then put a new one in, and you'll see I've got the pipette at the same location in my index finger. I put the finger up against the block, and I've tightened it. Then it's at the same location. I'm at about 12 o'clock, and it's not advanced too far forward or too far back, and I can drop it straight down and find it. Now, once you've made your beautiful pipette, you need to clean it because it's got all the solution in it and some glass particles. I use water, 75% ethanol, and 100% ethanol. And I clean it through a series of solutions. I'll aspirate and then eject the solution, maybe about 2 or 3 times in each solution, the water, the 75% ethanol, and then 100% ethanol. And then that's my setup right there. I'm using the Sutter XenoWorks digital injector, and I'm using that for nice control to make the pipettes. The other thing is, this is really nice. If you have an injector, you can use the high pressure to blow out the solution, but you do need to be a little careful, and I'll show that to you in a second. You're going to need to clean up afterwards. Yes, you need to take the entire system, not the entire system apart, but you need to take the top pedestal piece off. You need to remove the retaining ring and the beveling plate, and you need to clean the bottom of the beveling plate with 75% ethanol or degreaser. Do not get that oil or the 75% ethanol or the degreaser on the top of the plate, because it might ruin the surface or wash off the diamond granules. So I'm washing off the bottom of the beveling plate, and then you're going to clean the top of the plate with pure water, shown here. And then you're cleaning the optical flat too. Don't forget that, clean that off also. And that would be with ethanol and or degreaser. So you want to put the beveler to bed after you're done, which means after you clean the plate holder and you clean the retaining ring, you're then going to lay out the parts to dry on a bed of paper towels, including what I call the virtual screwdriver, since we're talking about virtual reality here. I did that because I forgot to put the screwdriver there. And it's good to keep one there at all times, so you're ready to put everything together and bevel. So keep your virtual or your real screwdriver off to the right side of your parts. And then cover the parts with a Kimwipe blankie, because we're putting it to bed, and that keeps everything dust-free. And then you're going to do the same thing. You're going to cover the optical flat with a Kimwipe. And then you're going to return tomorrow for more fun beveling. And I'm going to just show you some hazards here. This is kind of fun, but I have never actually injected anybody accidentally or driven the pipette into anybody but myself. And the pipette sometimes does go flying if you're using high pressure injector to clean it. So you need to point it away from you. And one of the hazards is stabbing yourself. And the other hazard is flying pipettes when you're cleaning it. So I just want you guys to be very careful if you're using a high pressure injector to clean your pipettes. Here is an example of me having accidentally stabbed myself with a beveled pipette. It's gone pretty far in. It did come out whole though, so I was lucky, but I did draw a little blood. Hopefully no one's too squeamish to see that, but it's a good story to tell. And here's the beveler in slow motion, high pressure. You will see on the left, bottom left, there it goes. It went flying because I didn't tighten the chuck tight enough to keep the tip from sliding out. So you really have to tighten those a lot. The other example here is a drawing of my best friend, and nope, see, I accidentally stabbed him in the eye. So you do want to avoid that too. Anyhow, I had to have a little bit of fun at the end of putting these slides together. And again, if you don't have all this equipment and you don't have the time or the expertise and you want to just buy your pipettes, you can do that too from Sutter. We do make a variety of custom pipettes. That's it. I think it's question and answer time for everybody.
Yep, thanks a lot.
Right.
Let's keep this slide up. This is a really nice sky. Let's keep that up for the question and answer session. Thanks a lot to the audience for staying on, almost everybody, even though we're a little bit over time. We have a whole number of questions. Hopefully everybody will stay on for that as too. Let me start with 2 questions that are loosely related to Telly. He had the first talk. One is about tags and events that show in the paradigm review. Can they be exported to show in analysis graphs and maybe even be exported in a filtered fashion?
Well, I'm pretty sure they could be filtered because they are metadata tags. Now, the analysis graphs, it's an interesting point. I haven't really thought about that, and honestly, I have to take a look on how we can do that. But right now, I can't think of a simple way to integrate the two together. I mean, there probably are ways to do it within Igor graphs by taking the data, the time of the tags, and then also of the graphs and putting it together. But we don't have a ready tool to do that in SutterPatch yet.
I can definitely see how that's a valuable suggestion, having events like I'm switching to a different solution now or something like that also show in a time course analysis graphs.
Sure. No, it actually makes a lot of sense to me as well, and it's something that I will definitely take a look at. And yes, thanks for the question and actually for the suggestion into looking at a new feature.
And the same person, loosely related, as I said, can specific metadata be exported? For example, series resistance, C-slow, time,
Yes.
for one routine, and can it be tracked over a paradigm? For example, comparing RS at the beginning with RS at the end?
Yes, as I mentioned in the talk, we have different layers of metadata tags. So, and you could do filtering on the different layers. So you could start, for example, at the paradigm level, and then use the filtering to only see a particular parameter. In this case, one of the cell parameters from a membrane test, for example. And with the filtering, you would then redraw the metadata window that will show all of the filter results with each sweep or with a routine. In this case, paradigm, routine, and sweep level would be shown.
Mm-hmm.
From the metadata, you can then use the copy to option to either copy that to a clipboard or to a notebook window and take it from there.
Okay. Then I have a question for Jake. What advances does ClearPixel have in the near future for the virtual laboratory platform?
Yeah, cool. We are currently working on two key features really for the virtual platform. One being multi-user functionality. So as an example, if we were to run the patch clamp module, you could have someone who is an assessor or a trainer put a headset on, and you could have a student or someone learning on the tools put a headset on, and they'll both be in the same environment, the same virtual environment, and they can both learn on the same tools and or skills on that particular thing. It's something that we've been looking at implementing for a while, because we are aware that obviously as an instructor you want to be with the person and guiding them through the procedure or the module. And the other thing is haptic enhancement. So how can you take these dexterity-based simulations and sort of bring them to the next level? Because with VR headsets, you tend to have controllers, which are very good at replicating, for example, virtual hands and how you pick up things and interact with them. The next step from that is to implement something along the lines of hand tracking. And the best means of that is to have the likes of a glove or some form of tool that can actually physically wrap around your hand and can provide haptic feedback. So when you pick something up, you can feel the sensation of picking something up, whether that's a pipette or I don't know, a glass jar or something. Essentially something that replicates those real world feelings. So those are kind of two things that we're working on at the minute.
Like a haptic glove?
Yes, yeah, exactly.
I envision something like that to be outrageously expensive still.
At the minute, it doesn't commercially make sense to start rolling it out as part of our product, but there's a few companies now that are coming out of the woodwork and are offering more cost-effective solutions for it. I think because it's so early stage at the minute, it doesn't really fit our sort of business model at the minute. And you're right, they are a little bit pricey, but I expect as VR becomes more and more widely adopted, people are going to start developing these solutions, and eventually we'll have that kind of technology more freely available.
Okay, another question for you. Has the release of the Apple Vision Pro changed the way individuals and businesses view the VR and AR technology?
I think with Apple stepping into the space quite recently as well, I think it's shown people the value and the offering that VR has at the minute. I think the marketing for VR over the years hasn't been as widely received by people. I think Apple stepping into the space shows that there's room for a consumer product, and that has kind of triggered people to look into other solutions. So more and more businesses are now looking at how they can use VR to enhance their training, their education, even more, I guess, sort of soft skills in like business administration. But for us, it's meant that more people are becoming more receptive to the idea of training, which is just a byproduct of Apple sort of announcing that they're stepping into the space. And I think over the next few years, it's probably going to be a case of the headsets getting more accessible, smaller, lighter, more powerful, to the point at which, we're going to have some very advanced tools at our disposal that give that sort of enhanced reality effect, so to speak. So it's definitely been a positive impact. I think for us in particular, the consumer aspect is less important, but given that it's sort of raising awareness as to the technology and its capabilities, it's definitely helped.
Okay, thank you. Question for Adair. Should I turn the beveler off in between beveling pipettes?
That is a very good question, and it's also a very bad idea to do that because there's a bottom belt that turns the bottom aspect of the pedestal, and then the top half of it is floating on oil and is being turned by magnetic force. And if the beveler is turned off, that magnetic force is pulling those two parts together, and the oil gets pushed out. And when that happens, the beveler starts to jerk and not rotate at all, or it doesn't rotate smoothly. So you don't want to turn the beveler off in between pipettes. You can leave it on for a whole day, a few days. It should just keep on rotating. For the same reasons, you want to actually have the beveler turned on when you put that plate on there too. So everything's rotating and moving so the oil stays between the plate and the optical flat.
Okay, thank you. And then there's two questions that are related, and I believe that would come from people who do electrochemistry. Can I bevel metal or metal-filled electrodes? And can I bevel at 90 degrees to make a flat tip?
The answer is probably no to both of those situations. Often the metal wire that is put in the pipettes is usually over 25 microns. And so if it's the size of a hair, which might be like 100, 125 microns, the beveler surface will just get scratched and damaged. The diamond granule surface is designed for glass and not for metal. If the wire is extremely small, it might be doable, but I have some doubts. Beveling at 90 degrees is a challenge. We did create an adapter for people to attempt that, especially with fused silica polymicro tubing. But again, the beveler is rotating and it's pulling the glass sideways. So even if you approach it at 90 degrees, it's going to be pulled and it's most likely going to be beveled at a slight angle. And also, I think there's just be so much glass hitting the surface, it's going to get pulled even more. And then also, I think it'll chip.
I could also envision it shattering in that situation, right?
Exactly, yeah.
Yeah. Okay, thanks a lot. Let's go back to Telly. Somebody's asking, why are my imported data files so much bigger than the original? Apparently somebody who's played with import already.
So one of the big reasons is the data format that we use for all our signals. As I mentioned, we use either 64-bit or 32-bit precision, which takes up a lot more space than what a lot of old data acquisition systems used to do, is to use integers and then apply all sorts of filter factors, gains and settings and offsets and so forth before you actually had a data set. All our data, as I mentioned, is completely scaled and ready to use. So that makes for a bigger data file.
Thank you. And somebody's asking, can I export my data as CSV, comma-separated values?
Yes, so in the table formatting section that I showed in set preferences, you could specify the different type of separators that you want to use, and comma is one of them, or tab or so forth. So that's all options.
Okay, thank you. Then let's go back to Jake. Actually, I have a question. You mentioned multilingual support. How important is that in life sciences? The old-fashioned paradigm is that if you want to do life science, you have to know at least some English, and most people I usually interact with are more or less fluent. Is that going to change?
Good question. I think the multilingual aspect of what we're building is more assistance, I'd say, for students more than anything. It's a problem that's been highlighted by a number of universities in particular. And again, this might be a bit more isolated to the UK. I'm not sure regionally how it differs, but more and more international students are coming through the system in the UK. And we've had for example, people who have gone through the education system and are now instructors or teachers and said, back in the day, I used to be doing my lab studies and I'd have my English professor, giving demonstrations on practicals and things. And I would be a bit overwhelmed because things are in different terminologies or they're not understanding things appropriately. So these days you can have like essentially plugins for the kind of tools that we're building that allow just the translation of certain languages. So we saw it as a bit of a solution specifically for education. I can't speak for the industry as a whole, but we thought in terms of inclusivity, if you're delivering, for example, one of our virtual modules to a class of people and you've got different languages, then what better way than to have the teacher speaking in whatever language they choose, in whether it's probably English, and then having it translate to everyone's native language. It was just born out of some of the problems that we've discovered in speaking with institutions.
One of the reasons I'm asking is also we discussed having localized versions for Sutterpatch software, for example, but with specialty products like we make, the sales volume is just not large enough to justify that. A lot of software products nowadays are not localized anymore. And I wouldn't foresee that to be a factor in sciences in particular, but that's probably a separate discussion that we should have in another environment. And another question from the audience for you, Jake. How do you see the technology evolving over the next few years? You've already touched on a few aspects, but how can you address that?
Yeah, so I think I mentioned some of the more hardware related, evolutions in the software. I think they're going to VR, and I solely touched on VR in this talk because there are a couple of other tools like augmented reality, which is a separate thing, but the tools themselves and the physical products, I think they're going to get smaller, they're going to get more accessible. It's going to get to the point where we have like a pair of glasses that you can put on, and whether it's learning in a completely virtual environment or a real environment that's enhanced by virtual augmentation, I think the hardware is going to get a lot more accessible and smaller, lighter, more efficient, and higher powered as well. In terms of the software, I think much like anything, for me, with a background in software and games development, things like 3D software only get better, to the point that in the entertainment industry, things like games, movies, anything to do with visual effects, it's becoming to the point where we can recreate things that are looking one-to-one real with what we would associate with reality. So the software will get better, the hardware will get smaller and more efficient, and I think in a few years we'll have some pretty cool technology at our hands. And I know that a few of the sort of big players in the VR sphere, and Zuckerberg with his quest for Meta to become one of the biggest suppliers of that, they're all saying that it's going to potentially replace things like phones. So it'll be interesting to see how that message kind of evolves. And I'm not sure I'd go as far as to say that it'll replace something like a phone, but it will be interesting to see how it impacts our lives in a few years.
Thank you very much. We have the questions coming in from the audience tapering off, I would think. So let's address another one to Adair. Do I really have to clean the beveling plate and optical flat after every use? And I think I can guess on the answer.
The answer is yes. What can happen if you're not cleaning it regularly is that the oils that are there will seep down underneath that base and they'll polymerize, and then your beveler will not be rotating at all, and then you'll need to take the whole thing apart and clean it, which will take you a few hours. So it's good to just take those few minutes to clean everything after each use. And again, you don't need to turn it off in between uses throughout that day. It's just at the end of the day, it's a good idea to turn it off and clean it.
I guess the answer you gave to this question is also part of the answer to the last question that we're going to deal with today. If my beveling plate is jerking, turning slowly, or not turning at all, what should I do?
It's best to clean it, and then there are instructions on how to do further disassembly to clean it even further. But sometimes what I'll do is I'll put some 75% ethanol underneath the plate, and then I'll get a Kim wipe and slip it underneath while it's rotating and try to kind of clean off what might be underneath the plate. I'll take some canned air and blow on that lower assembly and try to blow out any oils. One of the reasons it could be jerking is that they've assembled the top pedestal assembly while it was on top of the optical flat, or they put it on the optical flat when the power wasn't on and the bottom aspect wasn't rotating, and then the oils just get pushed out. The other reason it can jerk is if there's no oil or too much oil. So that 1 to 2 drops of oil is key, and using the right kind of oil. It's really a good idea to get the oil from Sutter. It's the right viscosity.
Thanks a lot. There's 2 or 3 more questions which we will address by email. Also, the person who asked the first questions for Tele thanks and is looking forward for potentially us implementing that feature. I would like to thank the audience for staying on and for the questions that they asked, for a lively discussion. And I wish all of you a great rest of your day, or a good evening, or a good night. Goodbye.